Greetings and salutations, the ranting engineer here. This episode I'm talking about liquefied natural gas, and I'm going to touch upon CNG, which is compressed natural gas. So natural gas, what is it? It's mostly methane. Most specs here in Alberta and Western Canada, you've got to have a burn value of at least 36 megajoules per meter cube. That's 36 megajoules per standard meter cube. So when you think about gas at atmospheric pressure, i.e. the gas that's around us, it's not very dense. So if you're trying to transport gas and it's in atmospheric, you just can't store much of it. So what you do is you liquefy it. Well, the density of liquefied natural gas, LNG, is way higher than even CNG, which is just compressed natural gas. CNG typically is stored at 3,000 to 3,500 psig. Now, liquefied natural gas has to be stored at minus 160 degrees Celsius, which means to get at that point, you've got to put a lot of energy into it. So there's two pieces to the LNG process. One is purifying the gas. So you have to make sure that you get certain components like mercury out of it. There's specialized heat exchangers which mercury reacts with. They're called brazed aluminum heat exchangers, which are typically used to help cool the gas. Now, there's several different processes to do this, but the general one is UOP has something that makes sure your gas is very clean, and to make sure the gas is removed of all water, because at minus 160 degrees Celsius, you could imagine you're going to make a little bit of ice. Anyway, so the front end of an LNG plant is basically gas purification. The second half, and I'll probably reference the Kenai gas plant, which is the one I'm most familiar with, you essentially have three cooling loops. So you chill, you compress, and you chill the natural gas in three stages to get it to minus 160 degrees Celsius. And that's all LNG is. You can't actually burn LNG. So you take natural gas, you compress it, so it makes it dense. You cool it until it crashes out as liquid, and you store it that way. You can't actually burn LNG. So you've got to turn around and vaporize it before you can actually use it. Now the key here is at minus 160 degrees Celsius, you have some fairly specialized metallurgy. So LNG is usually stored in high nickel tanks encased that are inside of concrete. So once you think about this, you've got to have energy to clean the gas. You've got to put a lot of energy into chilling and compression to turn it into LNG. Then you got to turn around and you got to add energy into it to turn it back into gas so you can burn it and use it. So yes, LNG is, we'll say, a clean fuel. But you need to understand that when you burn natural gas after you vaporized it, it still produces carbon dioxide. It still makes GHG. So when you hear this, it's a clean burning fuel, doesn't mean that it burns like magically and doesn't produce carbon dioxide. It's just because it's a simple methane molecule, when it combusts with oxygen, it forms carbon dioxide and water, and it very rarely non-combusts into other things like carbon monoxide and everything else. Whereas you take diesel and gasoline, quite often you have incomplete combustion. That's why they mean it's a dirty fuel. It's like burning, say if you burnt something like propane. Propane burns really clean, and then you go light up motor oil. Motor oil burns black and sooty and everything like that just because it's incomplete combustion. Now, CNG is just high-pressure natural gas. Now, you can understand high-pressure natural gas. You need some fairly skookum process vessels to contain this, fairly thick-walled. And the other trade-off with natural gas in engines is you tend to lose a little bit of horsepower just because the amount of energy per cube of natural gas, gasoline kicks its ass. So does diesel. Okay, so when you think about that, LNG is, we're not going to argue that's green. You just need to pay attention to what LNG is. It's just a method of storing large amounts of natural gas to ship it, to move it around, and to be able to then have this liquid that you end up vaporizing to use elsewhere, whether it be in furnaces, whether in vehicles and stuff like that. So imagine if you got to store this on a vehicle, you've got to have very special metallurgy to hold this minus 160 degrees Celsius liquid. Then you got to have special equipment to vaporize it. Pretty interesting stuff. Anyways, it's kind of the opening salvo as I'm going to start talking about more and more about hydrocarbon. Hydrocarbon we know is a CO2 emitter. My point is if we're looking at electricity, we're looking at LNG, there's a certain amount of, I want to call it spin doctoring. So again, LNG is a clean burning fuel. No, LNG is not the fuel. Natural gas is what you burn. It's clean in the sense that it usually has complete combustion. It still produces CO2. The energy per mole, per kilogram, whatever you want to do it, is not as high as other fuels. So I want you to think about that, and we're going to keep going through hydrocarbons. I imagine I'll start talking about, well, let's do biofuels after this, because this is one that's pretty cool. All right, have yourself a good evening.